In this lesson today, we're going to look at more equations, okay? So getting into more complicated solving equations. And so we were talking before about the distributive property. The distributive property, we have a number times two sets of numbers, or two numbers that are added. We can distribute that A to both. And that's the distributive property. That allows us to clear the parentheses. That's really useful, for example, if you had 5 times x plus 10, you wouldn't really be able to do anything with the x plus 10 because you're supposed to multiply it by 5. You can't subtract the 10 because there's these parentheses there. So here we would use the distributive property and we would get 5x plus 50. We were practicing that also with the negative sign. With fractions, if we have an equation that has fractions, we would multiply both sides by the common denominator, and that's going to allow us to clear the fractions. We'll see a few examples of that coming up. And then you want to make sure you combine like terms. So who can give me an example of some like terms? If I say 5x, who can give me a like term to 5x? Yes, 8x would be a great example, okay? So they have to have the same variables and the same exponents, and if we combine them, we could use addition or subtraction. We want to write equivalent equations with all variable terms on one side, and then we get all of the numbers on the other side. So we're using the addition property, which we talked about last time, and then once we get a variable by itself, we would be multiplying or dividing in order to get that x, that variable x, usually it's x by itself, and we could use the multiplication property for that. So we have basically the addition property means if I add or subtract the same number to both sides, then I keep the equality, and if I multiply or divide the same number on both sides, we see the C, then I keep the equality. Okay, so let's just try a few right here. So this one, we want to get x by itself. So what's the very first thing I can do to start solving for x? What would you do? Yeah, subtract 20 from both sides. Now, a really important thing that a lot of people will forget is they forget that negative sign. You want to keep the negative 4, you want to keep the negative, I should say, with the 4. And then what is 8 minus 20? Negative 12, great. And then what could you do to get x by itself now? Divide by negative 4, and we get x equals 3. Yeah? Okay, now that's solved. Is that good enough? What should I do to make sure my answer is correct? Plug it in. And so this is our check. So we take 20, we take the original equation, and wherever we see an x, we're going to replace it with a 3 equals 8. So we have 20 minus 12 equals 8, and we get 8 equals 8. Now, if you got something else other than 8 equals 8, then you would know that your answer is not correct, and then you'd have to go back and find your mistake, which is the reason why you want to show all of your steps. Okay? What about for the next one? How can we get x by itself here? What would I need to do first? Yes, use the distributive property. So I'm going to distribute the 4, and I get 4x minus 4 plus x equals 6 plus 10. I could have actually simplified that 6 plus 10, huh? Okay, what would you do now? After the distributive property, you're going to, I love it, combine like terms. You're using the vocabulary. So you have 4x and x are like terms. And how many x's do you have? 5x minus 4 equals 16. Those are also like terms. Great. And then what would I do next? Add 4. I get 5x equals 20. And then, wonderful, and x equals 4. And actually, I love it that you said 3 in a way, because sometimes we make little mistakes like that. And that's part of the reason why it's so important to check. If I were going, let's say I had an error, okay, and I had x equals 3 instead. I just want to show you what that would look like. If I take that 3, Because I even make these mistakes too, you guys. I just want to show you what it would look like if it was wrong. So here I would go order of operations. I'm just plugging the 3 in where I see an x, and I would have 4 times 2 plus 3 equals 16. 8 plus 3 is 11 equals 16. And this will happen sometimes. Students will often make mistakes, and I do too. That's part of the reason why we check, because if we plug it in and it's wrong and 11 doesn't equal 16, then we know we can go back and look for mistakes. Okay, so I just want to show you an example of what that would look like. There was one time I was solving a problem. We're going to get to this with fractions, and I did the problem over and over and over again. It was making an answer key for a Math 60 test. And it would not check. I kept checking it, and it had fractions in it, and I was like, what is going on? And I figured out, because I could see all of my work, that I had multiplied, 4 times 5, and I wrote 24 instead of 20 or something. Just like a simple mistake that we can make. And most of the mistakes that we make are to do with distribution. A lot of times I will see that students will forget to multiply the 4 by the -1, or they could have to do with signs. Dropping the negative sign is another big area of mistake. Okay, negatives can be really challenging. So let's look at the next problems on the next page. Continuing on. Now there's a couple of ways we can solve problems with fractions. We can, since we only have one fraction here and it's next to the x, I might not clear the fractions. I might just go ahead and solve getting x by itself, and then, so let's do that. What would we do to get x by itself here? What would be your first step, do you think? But before we do that, we want to get all of the numbers onto one side, right? So I like the idea of divide by 3, but could we get rid of the -17? What could you do to get rid of -17? Well, if you owe me $17, how about you pay me back? Yeah? 17. I was writing 4. So if we add 17 to both sides, we get 3/5 x equals, what's 17 plus 4? 21. Good. I'm glad you're helping me with the math. Okay. Now what could we do to get x by itself? Yes, multiply by 5. And at the same time, I could also divide by 3. That's the same thing as multiplying both sides by the, what do we call that? Yes. I thought it was called the refliprical. Oh. I'm going to make that joke like way too often, right? So 3, now do you want to cross cancel? I love cross cancel. 3 goes into 21 7 times. 7 times 5 is 35, exactly. And if we check that, we plug it in, 3 times 35 divided by 5 minus 17 equals 4. And so here I might even cross cancel again. 5 goes into 35 7 times. I get 21 minus 17 equals 4, and 4 equals 4. We didn't know if it was correct, so I put a question mark there. It worked out, so I give myself a check. Now, an important distinction is this 4 equals 4 is not the solution. The solution is x equals x equals 35. With this problem here, you have a lot more fractions going on. So this is the idea of clearing fractions. How many people would prefer that problem D had no fractions in it? Okay, I think it's unanimous. We pretty much all agree. Let's get rid of the fractions. Well, a couple of things to realize. Okay, I'm going to give you a sample problem. If I said x over 2 is equal to 1 over 2, could anyone tell me what x is just by looking at that? It's pretty obvious, right? Would you all agree that x is 1? And that's because if the denominators are the same, then we can say that the numerators are also equal. If the denominators are equal, then the numerators are equal. And so that means that x has to be equal to 1. Everything here has a denominator of 5, but the 4 has a denominator of what? 1. Can I make 4 have a denominator of 5? How would I do that? I could make an equivalent of fraction, right? Anytime I want to make equivalent fraction, I could multiply this number by 5 over 5. So I get 3x over 5 minus 7 over 5 is equal to what? 20 over 5. 20 over 5, by the way, is the same thing as 4. So I'm not multiplying by 5. 5 over 5 is the same thing as 1 whole. So what I'm doing is I'm making an equivalent fraction, and I'm doing this because if they all have the same denominator of 5, then essentially I can multiply both sides. I can multiply this by 5, this by 5, and this by 5. And look at that. The 5s, they cancel. Or you could think about it like this problem. If all the denominators are equal to 5, then that means all of the numerators are equal, right? So that's what we call clearing fractions. We got rid of the fractions by making them all have the same exact denominator. It's called clearing fractions using the idea of a common denominator. And I have actually some more videos on this on my YouTube channel, so I can give you guys some more examples of this as well. So this is what we call, this problem, I did it by clearing fractions. Oops, fractions. Okay, because this is a much easier problem to solve, wouldn't you agree? How can we solve this problem now? We want to add 7, correct? 3x equals what? And then what next? Get x by itself. X equals 9. And because I ran out of space, I'm going to just take a clean sheet of paper here, and I'm going to do the check. So I have 3 times 9 over 5 minus 7/5 equals 4. I want to know if this is correct. This is my check. So I get 27 over 5 minus 7 over 5. Is it equal to 4? What's 27/5 minus 7/5? 25. Is 25 equal to 4? 4 equals 4. It probably would be good to do a few more examples of clearing fractions, but let's move on since we don't have one right now in our packet, and we'll circle back to that, okay? Because you're going to have some to practice in your activity as well. All right. But the idea with clearing fractions, and this is one of the more complicated problems, types of problems to solve, is to get everything to have the same denominator. Okay, and I'll come up with some examples that work a little bit better that are not on our sheet. Okay, let's go on to the next thing. We have a lot of different terms. So what strategy would you use to solve problem E? First, start with combine like terms, right? So what are our like terms on this side of the equal sign? Yes, so that's 10x minus 5 equals, what are our like terms on the other side of the equal sign? Yeah, and is that a positive or a negative 10? Yeah, so we have x minus 4. Is that what you got? Okay, and then what should we do to isolate x? What do we do now? We have x's on both sides of the equal sign. Is there a way to get the numbers to go on one side and the variables to go on the other? How would we do that? I could subtract x from both sides, correct? And then what would I do with the 5? Maybe add 5 to both sides. I'm sorry I did that in one step. I should have done 2 different steps. But here, if I combine my like terms, 10x minus x, how many x's is that on this side? 9x. What happens to the 5 if I have negative 5 and positive 5? This x is gone, and then what do we have left on this side? Oh, actually, is that yeah, that's negative, sorry. And that's 1. Good. Now what should I do to solve to get x by itself? Divide both sides by 9. X equals, what's 1 divided by 9? It's actually 1/9, right? Because think about it this way. If I brought a candy bar to class and there was 9 of us and we were going to split it up evenly, would you get a whole candy bar? Would you get 9 candy bars? You would only get 1/9 of the candy bar, right? You would have a fraction of the candy bar. So I bring that up because a lot of times students, when they get the answer as a fraction, they don't want the answer to be a fraction. They're like, no, don't make it be a fraction. But it can happen that we get answers that are fractions. And then we can also check this. Because I don't want to go through all the painstaking work of getting our common denominators, it's just going to take me too long. I'm going to show you how you might check this on the calculator. So if I wanted to plug in, and I'm just going to write calculator check here. Even though we could do all of that work, and we should really, push ourselves to do it, I just want to show you how you can go 7 times. If I want to put the fraction 1/9 in, it's literally 1 divided by 9. 1 divided by 9 is a fraction. Okay? So 1/9 minus 5. You see how I'm just plugging this in. 3, plus 3 times 1 divided by 9. Okay, on that side, I get negative 3.8 repeating. And I know it's repeating because the last digit is a 9 and they rounded it because you can't repeat on forever on the calculator. And then if I plug it into the other side, I get 6 plus 1 divided by 9. Again, that's 1/9 minus 10. And look at that. I get that it's equal. So the main thing is, if you're going to use the calculator to check, just tell me that you're going to do that and then show me that it worked out, okay? And so I just didn't want to go through all the steps of plugging it in. Even though we could do that and we could get common denominators, it would be all great. It would be a little tedious though. I'm not going to lie. Okay, let's go back to F now. And how would you like to solve F? What would you need to do first? I love it. Distribute 6x plus 4 equals, here you're going to distribute, what do you get? 20x minus 24, right? See, that was the same mistake I made on that problem that I had to do over and over and over again. Okay, and then what do you want to do next? What do you think? You could either subtract 20x from both sides, or you could subtract 6x from both sides. What do you think makes the most sense to do? And by the way, either way is correct. And why do you choose the 6x instead of the 20x? I love that. That's exactly how I feel about it. I don't want to have negative numbers if I don't have to. Let's frame everything as positive whenever possible. Okay, then what should we do? Next step. Shout it out, anybody. Add 24, and we get 20. Good. And what's our last step? Divide by 14, yeah. X equals 2. Good. And again, we can check that by plugging it in, okay? So go ahead and take a moment to check that.